Hi guys, my name is Jesslyn and I am doing some videos in geometry, and so this video is over parallelograms. I'm going to go through some properties and stuff of different shapes, and then you can use these in proofs that you do in your geometry class. So first of all, let's talk about parallelograms. And I always have trouble spelling parallelograms. Parallel's kind of a hard word to spell. I'm like, does it have two R's? Does it not? But parallelograms, hopefully I spelled that right. So a parallelogram is a quadrilateral whose opposite sides are parallel. Quadrilateral, the word quad means four sides. So a parallelogram is a quadrilateral. How we name a parallelogram, if we have the shape parallelogram, and we have A, B, C, D, kind of a bad parallelogram, but let me redo that because these sides are supposed to be parallel. A, B, C, D. So two pairs of, and then I'll do, and then these. And so the opposite sides are parallel. To name a parallelogram, you can use the symbol, just that little symbol, and then just name it by its vertices. So parallelogram A, B, C, D. So you just use the little symbol, you draw a little bit of parallelogram. Okay, so the properties of a parallelogram. So let's talk about the properties of a parallelogram. So the properties of a parallelogram are, and I'm just going to say them, so just watch them. If you do need to write them down, just pause the video. So opposite sides of a parallelogram are congruent. So I'll draw a parallelogram so we can talk about it. So opposite sides of a parallelogram are congruent. So those two are congruent, and then these two are congruent. So that is one property. Opposite sides of a parallelogram are congruent. Opposite angles of a parallelogram are congruent. So angle B is congruent to angle C. Angle A is congruent to angle D. And let's start writing these. So AB is congruent to CD. And AC is congruent to BD. And then angle A is congruent to angle D, and angle B is congruent to angle C. So we know two properties. Opposite sides are congruent and opposite angles are congruent. Those are our two properties so far. And then consecutive angles in a parallelogram are supplementary. So angle A plus angle C, so consecutive, they're side by side, they're supplementary, equal 180. And angle B plus angle D is also 180. So consecutive. Also, I forgot about these, angle A plus angle B is equal to 180 because those are consecutive too, consecutive angles, they're side by side. And then angle C plus angle D are also 180, okay? So consecutive angles are supplementary. So that's the third property. The fourth property is the diagonals of a parallelogram bisect each other. And what we mean by that, the diagonals here, when they bisect each other, that means this right here and this right here are congruent, and then this right here and this right here are congruent. I'm actually going to change that. So 3 and then 4 right here, because we already have one congruency mark here too. So what it's saying is when they bisect each other, when they intersect, it splits it into two congruent parts. So if I name this O, the middle part O, then AO is congruent to DO. So AO is congruent to DO, and BO is congruent to CO. So those are the four properties of a parallelogram. And then how can you tell if a quadrilateral is a parallelogram? Check the four properties. Check to see if opposite sides are congruent, opposite angles are congruent, if the diagonals bisect each other, and if consecutive angles add up to be 180. So a quadrilateral is a parallelogram if opposite sides are parallel. So you could check the properties, but if this one thing is true, then it is a parallelogram and those properties apply. So a quadrilateral is a parallelogram if opposite sides are parallel, okay? If opposite sides are parallel, then it is a parallelogram. So we have this. And so opposite sides, if they are parallel, and then this side is parallel to this side, A, B, C, D. So if AB is parallel to CD and AC is parallel to BD, then it is a parallelogram. You can state that it is a parallelogram. So in your proofs, if you prove that the opposite sides are parallel, then you can state that it is a parallelogram. If a quadrilateral is a parallelogram, then opposite sides are parallel. So that is the converse of it. If a quadrilateral is a parallelogram, then opposite sides are parallel, okay? So that's the property. And then to test it, if opposite sides of quadrilateral are parallel, then it is a parallelogram. So make sure if you need to test that, and then you can say that it's a parallelogram. So here are your theorems that we are learning. So parallelogram. So here's theorem 1, and I'll draw it because these are the theorems that you are going to be using to prove parallelograms. If both pairs, so theorem 1 says if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So if both pairs, it has to be both, not just one. If both pairs of opposite sides of a quadrilateral are congruent, then you can already state that is a parallelogram. That's the only thing that needs to happen. So if AB is congruent to CD, so this is theorem 1, and AC is congruent to BD. If both pairs of opposite sides are congruent, then it is a parallelogram. The second theorem says if one pair of opposite sides of a quadrilateral are both congruent and parallel, then the quadrilateral is a parallelogram. So you only need one pair, but they have to be both congruent and parallel. You have to prove that. So if AB is congruent to CD and AB is also parallel to CD, then you can prove it. Or, we can do or, AC is congruent to BD and AC is also parallel to BD, because you can just pick one of the sides and they both have to be congruent and parallel, but one pair of opposite sides. So that's theorem 2. Theorem 3 says if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. That has to be both pairs. So if angle A is congruent to angle D and angle C is congruent to angle B, then we can state that is a parallelogram. So both pairs have to be. And then finally, theorem 4. Theorem 4, go down here a little. There we go. Theorem 4 says if the diagonals of the quadrilateral bisect each other, then the quadrilateral is a parallelogram. So if we have the diagonals and they bisect each other, which means that this is congruent and this is congruent. So if you can prove that AM is congruent to MD and BM is congruent to CM, then you can state that it is a parallelogram. So if the diagonals bisect each other, because you have to prove that they bisect each other, and if they bisect, that means AM and MD will be congruent and BM and CM will be congruent. If they're not congruent, then the angles don't bisect each other, they just we call intersect each other, okay? So it has to be bisect. If the angles bisect, then you can say that it is a parallelogram. Okay, so so here are 5 ways to prove that it is a parallelogram. If we can prove that both sides of opposite sides are parallel, then we can say that it is a parallelogram. And the reason why, it's not a theorem, that is just a parallelogram by definition. If we go back at the beginning of the video, we said a parallelogram is, it is a parallelogram if both pairs of opposite sides are parallel. So you can prove that it's a parallelogram by using its definition. The second way is to show that both pairs of opposite sides are congruent, which is our theorem 1. If you can prove that both sides of opposite pairs are congruent, then you can say it's a parallelogram. The third way is show that one pair of opposite sides are congruent and parallel. So that's our second theorem. If we can prove that one pair are both congruent and parallel, then we can say it's a parallelogram. And then the fourth way, show that both pairs of opposite angles are congruent. So if we can prove that both pairs of opposite angles are congruent, both pairs, then we can say it's a parallelogram. And if we can show, the fifth way is show that the diagonals bisect each other. If we can, which is the fourth theorem, if we can prove that the diagonals show. So there's 5 ways, the 4 theorems, and then the definition, just by definition you can prove it. So, here's some examples of what you might see for a parallelogram, and we're going to use either the theorems or the definitions to solve. So, find the values of x. I'm telling you that this is a parallelogram. So I'm telling you that it is a parallelogram. So all properties, all theorems, everything apply. So we can use the theorem that opposite sides of a parallelogram are both congruent. Then we can set these up. So if opposite sides of a parallelogram are congruent, we just set it up. Y plus 2 equals 2y, and 6x equals 4x plus 8. Because we know that this is a parallelogram, I'm telling you it is. So opposite sides of a parallelogram are congruent. So we solve it. I'm not going to teach you how to solve. I am going, if you need that, go watch the solving equations. And so x equals 4 and y equals 2. And so there you can use that theorem to solve this parallelogram. Thank you for watching my video on parallelograms. Bye.